All right, let's talk about building a real fortress around your data. And I'm not just talking about the usual stuff like firewalls. We're going deeper. We're talking about vSphere VM encryption, your data's own digital suit of armor built right into the core of your virtual world.
Okay, let's just cut right to the chase with a question that, honestly, should keep you up at night. Forget about all the sophisticated remote hackers for a second. Just picture this. What happens if someone with a key card just walks into your data center, unplugs a server or yanks a drive, and walks right out the front door? Because here's the cold, hard truth. If that data isn't encrypted where it lives, what we call at rest, then all your fancy network security means, well, pretty much nothing in that situation. An attacker with the physical disk has quite literally the keys to your kingdom. It's a blunt reminder that at the end of the day, your data is only as safe as the physical storage it's sitting on. So how in the world do you defend against a threat that fundamental? Well, this is where VMware comes in. And not at the application layer or the network layer, but way down at the very foundation of your virtual infrastructure. It's time we introduce the hypervisor's own security shield, vSphere VM encryption.
Now, the really crucial thing to get here is where the magic happens. This isn't some agent you have to install inside every single operating system. Nope. This is a feature that's baked directly into the hypervisor itself. It encrypts everything, the virtual disks, the config files, the whole shebang, before it ever gets a chance to touch the physical storage.
And the process itself? It's actually beautifully simple. Your virtual machine is just doing its thing, generating data like it always does. But then, bam, the ESXi host intercepts that data stream and encrypts it on the fly. Only after it's been turned into unreadable gibberish is it actually written down to your storage. So it's secure from the absolute moment of its creation. So that's the what. But look, to really trust a security system, you have to understand the how. So let's pop the hood and take a look at the actual mechanics, the keys, the industry standards, and the policies that make this all tick. The whole system really hinges on how you manage your encryption keys, and you've got two main choices. First, you can use an external key management server, or KMS. This is great because it speaks the industry standard language, KMIP, so it can talk to lots of different systems. Or, for a more streamlined setup, you can use the vSphere native key provider, which is built right into vCenter itself.
Now, vSphere uses this really clever two-key system to keep things extra secure. The first key is called the Data Encryption Key, or DEK. You can think of this as the workhorse. It's a totally unique key, and every single VM gets its own. This is the key that does the actual work of scrambling and unscrambling that specific VM's data.
Okay, so if every VM has its own key, you might be wondering, how do we protect all of those keys? Well, that's where the second key comes in, the Key Encryption Key, or KEK. The KEK's only job is to encrypt the DEK. It never even touches the VM's data. It's kind of like having a master key to a secure vault, and inside that vault are all the individual keys to the safe deposit boxes.
And what about the algorithm doing all this scrambling? Well, it's XTS AES 256. Now that might sound like a mouthful, but all you really need to know is that AES 256 is the gold standard for strong encryption, used by governments and banks worldwide. And the XTS part just means it's a special mode that's purpose-built and extra secure for protecting data on disks. So the cryptographic foundation here is absolutely rock solid.
All right, the tech is obviously very cool. But what does it actually mean for you day to day when you decide to flip the switch? Let's get down to brass tacks and talk about the verdict, weighing the real-world benefits against the things you really need to consider.
On the benefits side, the wins are huge. You're getting top-tier data protection, which is a massive help for compliance with things like GDPR and HIPAA. The security is so much simpler because there are no agents to manage inside your VMs. Plus, you get secure mobility with things like encrypted vMotion. But there's no free lunch, right? You have to consider the other side. Encryption takes CPU power, so having modern processors with the AES-NI feature is absolutely crucial. That offloads the hard work to the chip itself. Also, since the data's scrambled before it even hits your storage, some of those fancy storage features like deduplication won't work as well. And, of course, managing your keys is everything.
And that brings us to what is, without a doubt, the most important takeaway of this whole discussion. Let me be crystal clear. Losing the keys means losing the data. Period. There is no backdoor, there is no recovery tool. If you lose access to your key encryption keys, that data is just a pile of useless bits forever. Having a bulletproof backup and recovery plan for your key manager isn't just a good idea, it is an absolute non-negotiable requirement.
So this all leads us to one final big picture question. As we continue to virtualize everything, moving workloads between servers, across data centers, into the cloud, we have to stop and ask ourselves, is our security strategy actually keeping up? Or is it still stuck thinking in terms of old-school physical servers and simple firewalls? That's the critical question we all need to be answering.